Well, here we are again, and I'm scooting around in the chair making this camera go nuts. It's week 6, cis204, Unix shell scripting and utilities, and this is part 3 of the week 6 online lecture. So without further ado and getting out of this cheesy camera, we're going to jump right back into the lecture where we left off. We were talking about an example of all export. So there's a couple of shells that we'll create in class, and we'll do this in class. We're going to create a couple of shells. We'll use VI, of course. Man, I hate VI. The first is export 1, and the second is going to be the shell export 2. So there's the shebang line, and notice I'm using bin shell here, not bin bash, but we all know what that points to. Foo equals the first statement, and I'm going to export bar equal the second statement, and then I'm going to invoke the shell export 2. The shell export 2 is going to be run as bin shell also, and it is going to echo $foo and echo $bar. Where did we set foo? We set foo here. Foo is going to equal, the variable foo is going to equal the first statement. The variable bar is going to equal the second statement. Now notice what else we've got here. These special ISO 8859 double quotes. So, you know, this is a slide that was exported from an ODF format to a Microsoft PowerPoint format. Yuck. Okay, so let me go to ATSCIS here. And you notice that pardon me, I do have an export 1 and an export 2, but they're in a directory called .odds and ends. So I'm going to go to .odds and ends, and I'm going to look at these two. So let's do a more export 1 and take a look at what that says. So there's bin shell, foo equals the first statement, and then it's going to issue that command export 2. So let's do a more on export 2. Pretty simple. Give me $foo, give me $bar. Okay, so the idea is predict what of these things it's going to show. It's going to set foo, it's going to set bar, and then it is going to run the shell export 2, which will echo foo and echo bar. In other words, they're going to echo the contents of the variable foo, echo the contents of variable bar. If I run the command export 1, what do I expect to see? If I told you the only thing I'm going to see is the second statement, would you believe me? You have to, because that's all it's going to do. What happened is, if I go in here and VI the export 1, and change this to wrong. Let me insert export. There we go. Escape. Do that. Run that command again. Now the first statement and the second statement. And the reason is the $foo did not live once the shell export 1 was finished. What do you mean it didn't live? Because export 1 was running when I issued export 2. No, not really. What happened is export 2 is a child of export 1. Remember, export 1 will shut down and wait. Now, let's see here. Echo $foo. Nothing. Because those shells are gone. If I set that variable in the bash shell, it would be available in any shell as an export. It would be available in a shell that was a child of the bash shell. So anyhow, okay. So that's what you saw. It's a bit convoluted, but we'll practice this in class. So let me clean this up, get that out of here, and we're going to go on to the next slide. So So you're going to make both shells executable. They run export 1, and we just talked about what happened and why it happened. So we talked earlier about a set-o built in. There's also a shell option, a shopped alternative. So it comes with the more recent versions, the 2.x version and up of Bash. And so we're running on 4.2 in ATS CIS, and 4 and above actually. We have the shopped options available. And it's a superset of the options that are available in set. So it's the set options plus. The syntax is a little bit different. It doesn't use the -o plus o. It uses a -s to set and a -u to unset. I could get in trouble here pretty quickly. It uses the -u to unset the option. So for grins, we're going to do a shopped -p and see what options are available. And as you can see, there's quite a bit. So jump out of that. We'll get a chance to take a peek at these in greater detail in class. So prompts. And the very beginning of time, the shell prompt was a $sign. Just a plain $sign. But look what I've got here. If I cd back to my home directory, I get this inside square brackets hbecker3 at ats-cis space tilde. Let me do this. There's the $sign. Yep. Guess what? Because I'm in K-shell, I don't have the same controls that I had in the bash shell. So I have to type out clear. The control L doesn't work. Okay, so there we have just the plain $ prompt, and that's the first prompt that was available. So let me get out of K-shell. But you can display a lot of information inside the prompt. Now, if you get really crazy with putting things in your prompt, you run out of width on the line. So you basically take up a whole line. So there's a couple of examples that we'll take a look at in class on in the Unix shells by example. There also is a secondary prompt. So if I do this, if I echo open quotes here, hello, I should see another prompt, but not the primary prompt, the secondary prompt. There it is. Hello world. Close the quotes. It gives me hello world on 2 lines. It's because there was a new line in there. Okay. So we'll take a look at the explanation on page 771 in class. So now the fun thing is you've got a search path. This search path is a colon separated string of directory structures used by the shell to find the location of commands entered on the command line. So if, for instance, here's an example, copy /bin/ps to a file called myps. Do an ls-l on myps, and it comes up with myps. So I type myps, the command's not found. I echo $path, and notice it's not there because where's it at? It's under home Hugo at that point. Okay. So here we go. It is not recommended to add the current directory to the path string, and the current directory being a dot. If the command is in the current directory but not in the path variable, use a // preceding the command to invoke the command. So let me take a look and see if that command is still there. Let's clear this out. .my, and what was that command? myps. my_ps. Nope, it's gone. So let me go back here real quick and we'll do this. Copy bin ps to my_ps. Okay, /my_ps. There we go. It works. Echo $path, right? There's the path. If I wanted to, I could do this. Export path equal dollar path colon dot my underbar PS. There it is. Okay. Echo dollar path again, just for grins. I wanted to show you this because I do not put the current directory in the path, and the dot is the symbol for the current directory. So there it is at the very bottom. That's why the myps command worked there, but did not work here. Okay. It's a security issue. You don't want dot in your path, just the way it is. So there's a couple of examples that you can look at. There's a command called hash, and it keeps track of frequently used command, which improves the efficiency. It saves the path to the command rather than searching for it. So it speeds things up a bit. So if I do a hash, you can see that I don't use very much, at least in that session. If I do a hash over here, I may get something better. So it looks like I use grep, but I use ls quite a bit. So that path is going to be sitting in there. So, okay. Let's move. Oh, well, okay. Well, here, at one point on my laptop, you notice there were 42 hits of grep, which means I must have been doing something fun. So we talked earlier about the sourcing a environment file. The source command, or dot, runs commands in a script but doesn't create the child process. So it'll run the commands but inside the current process. You often use it after updating. So you update the dot profile, your dot profile, and then you source it, dot space dot profile. That will set those variables in the current shell, the shell you're using, rather than create a new shell to go out and set the variables. So the variables are set by the command become part of the current shell's environment when you source them. However, now fun thing is the dot profile is hidden. Hidden, yeah, really. ls space -a, and you can see the hidden files. Not a biggie. So the command line. The first word entered on the command line is the command to be run. The command runs according to the type it is in the following order. So it'll run aliases, keywords, functions, built-in commands, then executables and script. Now, do I have any aliases set? Well, let's take a peek here. So alias, and I believe it was -p, print. Oh, look. egrep is egrep with the POSIX color equal to auto. fgrep is fgrep with the color equal to auto. grep is the color equal to auto. The alias L gives me more. The alias L dot gives me the ls space -d dot splat dot dash color equal auto. So L dot, what does that do? Gives me those. Cool. Now, LL gives me an ls -l. There's the long listing. Okay, let's do the alias again. There we are. You see the M equals less and VI equal vim, and then alias which equal alias pipe it to user bin which TTY dash only. So that's what, when I type the command which, that's what's actually happening in the background. Okay. So the type tells you what type of a command you are using. So if I clear this, if I do a type pwd, and remember the pwd command is built into the shell for efficiency. pwd is a shell built in. So word count, type wc is in user bin wc. Cool. Type M M is alias to the command less. Okay. Now this is working out. Now, the commands are executed in a specific order. There are 3 built-in commands that can change the order of command line processing. So if we go back a bit here, they run according to type in this order. It'll run an alias before it'll run the executable or the script. It will run a keyword before it'll execute a built-in command. It will run a function before it'll run a built-in command. But I can change that if I go forward here. If I issue the command, then I won't be able to use the alias. Keeps aliases and functions from processing. So if I do a command L, well, I have to type the whole thing. Command L, it'll show command not found. Now, here's the command L, and let's do an ls real quick. So let me cd into files, and we'll do this, and we'll do a L data file 1. So there we go. Okay. If I do a command L data file 1, command not found, because it's not going to run an alias. If I do a command more data file 1, it'll run it. Why? Because more is not a built-in. Now, if I do a built-in wc data file, yeah, notice it's having a hard time here. Why? Because wc is not a built-in data file 1. There's the word count. Okay. Enable will turn a built-in on or off. If I turn a built-in off, I have to use the system. If I do a which pwd, there is a user bin pwd. It uses the built-in. But if I do this enable built-in, I can turn that pwd off. I can turn the built-in command off. Okay, so there's an example of how command will be worked, and you saw that earlier. Here's an example of the built-in, and here's enable being done. Enable-n pwd. You can see how that works. The other thing you need to know is there's an exit status. After a command terminates, it returns an exit status. It can be a number from 0 to 255. 0 is reserved for successful operation. Now, the other thing reserved is a 127. A command not found will return an exit status of 127. Also, the exit status 128 is a fatal signal, and it's accompanied by the value of the signal that caused it to die. So if I do an echo $? And this is a command you need to know and love. The last command that ran, which was the which pwd, echoed or completed successfully. That is, that echo $? tells me what the exit status is. So what have we got coming up? Well, we're going to continue interactive bash. We've got there's a third error, but you'll be able to figure that one out. In fact, that's what we're doing right now. Okay. You do need to be reading chapter 13. So at this point, this is a conclusion. This is part 3 of week 6 of cis204, Unix shell scripting and utilities.